So today we are going to talk about building a retrieval augmented generation system for a medical company. And we're going to dive into the technical challenges and the product challenges, which can be huge, as we just saw in this morning session. So very quick words about myself, but you already said what was important. So Sikara is a service company building data science and data engineering products. And some examples of projects I worked in are object detection in videos and matching, so working with vector databases before they were famous and before they were mature, which was a bit trickier. Risk detection on oil platforms, RAG for a medical company, and error detection in invoices. So here are just a few examples. So diving into the Vidal. So the Vidal, who here knows what the Vidal is? It's normal, it's French. So basically the Vidal is a French reference for all the doctors, which contains the documentation about all the drugs. So every time you go to the doctor, they just look it up, all the information on the drugs they want to give you. And I'm going to straight away give a very quick demo of what we built for them. So let's say I'm a doctor and I have a patient that come to me and he wants to get operated, but is under Eliquis. So how long to stop Eliquis before an operation? I'm not quite sure what Eliquis is, nor is it's not a requirement to understand what comes next. And so basically, first it finds the right information in the Vidal, starts by reformulating the question to add some extra information. We'll dive into this, and then provides an answer and cite directly the Vidal because it's for doctors. So if you just give the generation, which can hallucinate, it's not convincing enough. So we directly cite the right part of the Vidal, which contains the information. And here, the doctor now knows the patient needs to wait 48 hours before surgery. Just a quick disclaimer, all the product, all the prompts, etc. is in French because it's for French doctors, so all the demonstrations we may see are done with Google Translate, which works quite well, to be fair. Just with a quick show of hands, who here is familiar with Retrieval Augmented Generation? Okay, cool, pretty much half of the room. So very quickly for people who never saw it before, the idea is to use models like ChatGPT, but before that, retrieving the right information on a large base of documents to provide it to ChatGPT and say, all right, given this question and these documents, answer my question. So a little bit of theory. So the Vidal is composed of monograph. And the monograph, basically for each drug, there is a monograph and it can be very long, contains table and basically all the information a doctor may need to completely understand the drug. So you may see the little slider here when it's moving. So you can see the page is definitely quite long. And basically you have an active ingredient, which is basically the international non-proprietary name. So, for instance, paracetamol. But then there are a lot of brand names based on paracetamol. So there you have the generic, the brand name. You have different dosage, and each of these combination is a different monograph. So you understand how you end up with so many of them. And as we saw, it can take up to 3 minutes because it's very long. From user interviews, we found out it can take up to 3 minutes to find answer to a question in a monograph for a doctor. So To find such answer, a first approach would be just to ask ChatGPT the question, and most of the time it does have the answer. It does have the answer. The problem is that it puts a lot of useless text, and the sources are not provided. And even if it would cite its sources, you cannot really control them. So this is a problem to give something reliable to the doctors. So the solution is to build a retrieval augmented generation system to basically base a model directly on the documentation of the Vidal, as we all understood. And there are a lot of tools off the shelves, like this one, Quiver, where you can basically easily put documents and ask questions, which was a good starting point for our product. But is this performant enough, taking something off the shelf? So to know if it was performant enough, during our user interviews to basically better understand what we had to build, so we have some convictions, and then we do some go-ands with the doctors to see if our convictions are true or not. And during these interviews, we also ask them, what did you ask to the Vidal last week? And so we can collect 100 questions that doctors really ask to the Vidal, which will be a first basis for iterations. A first data set, of course, it's not huge, but it's a starting point. So for instance, here's a question a doctor may have. Are the side effects of clamoxyl in liquid form and in capsule form the same? The search time was 3 minutes and 16 seconds. The obtained answer was yes. And here the monograph the doctor based his test on. So basically we retrieved a lot of them, but it's more like for metrics purposes. In reality, the doctors only used the clamoxyl gelule form, the first one, and the second one, which is basically the drinkable form. And so we have a question, we put it in our copilot, it gives an answer, and we have 3 types of label. The first one is OK, if the doctor considers it's OK. I don't know if a doctor says, if the copilot explicitly says it does not know the answer. And KO, if the model says to consult a doctor, which does not really make sense because it's in the hand of doctors or the information is false or incomplete. And our initial objective is to have 0 KO question and the least I don't know answer over the 100 questions, our initial data sets. So this was the architecture of our initial RAG. So basically, we have the monograph. We chunk them, so we divide them into chunks of 8,000 tokens, because 8,000 is the limit of the embedding models we are using. Then we use an embedding model which basically represents the information. So it's a model which has been trained to semantically put so basically it creates a vector out of each piece of documents. And the idea is that 2 vectors which are close represent 2 documents which semantically mean similar things. And we put all of this in a vector database, which is basically a system optimized for storing and querying these vectors. And then a healthcare professional writes a question. The same model is used to create a vector, and then we ask the vector database what are the vectors which are the closest to our query vector, and basically we retrieve some chunks, which, in theory at least, are all the parts of the Vidal which are semantically the closest to our question. We put this in a prompt. So saying, all right, given all these documents, answer this question, and say you don't know if you don't find any relevant information in these documents, which really basically mitigates the hallucinations. And finally, we get our answer. And so using an off-the-shelf RAG, like Quiver, for instance, for this specific use case, this is the performance we get on our initial data sets. So it's quite good because we did not put a lot of engineering into that, but it's not nearly good enough for what we want to build. To give you some concrete idea of why some stuff are wrong, I don't know, etc., I'm gonna just show some examples. So to the questions we just saw earlier, are the side effects of clamoxyl in liquid form and capsule form the same? First, it's saying to consult a healthcare professional, which is not what we want because it will, if we output stuff like that, we will really struggle with user adoption. And it's only outputting sources related to clamoxyl in capsule and not in liquid form. So the answer it's providing is only partial. Here is an I don't know question. We are asking what precaution should be taken when prescribing detontial for a diabetic patient. And basically the model did not really pick up on detontial, which was based here the keyword, but more on like diabetic stuff. And so it outputted sources related to glucose, etc., which wasn't what we were expecting. And here's an answer which was correct. If a patient took too much of this drug called propranolol, then the model says it should be prudent to not leave the patient home because an overdose, if you do an overdose, you have like a lot of stuff can happen which are not stuff you want. And once we have this initial model, we can deploy it and we can begin to monitor the beta users. The beta users will really be people internally working at the Vidal. We don't want to expose it yet to real users, of course. And Langsmith is one of these many tools like Literal AI, Langfuse, etc., which are all kind of the same. And they allow to easily monitor your LLM applications. And one line is what is called trace. And you can basically, when you click on the line, see all the operations your question went through before giving the answer. And what's great with these kind of tools is that there is a playground button, which allows you to replay a prompt. And what's great is that it allows to basically put this tool in the hand of like business experts or product owners, which have much more medical knowledge here than the data scientists, to basically help with the prompt engineering iterations. And so this is our initial answer. Can we actually improve it? So through some analysis, the first thing we find is that our chunking method, so I told you at the beginning, we'll just take each monograph and split it randomly every 8,000 tokens. So this method is quite naive, it's not perfect, and it poses two problems. The first one is that the start of the section, so given this is a chunk, let's say this is a chunk, so we will just randomly split it. So we will talk beforehand about fertility, pregnancy, and breastfeedings, and we will cut this part in two, and the end of the side effects session will be missing as well. So when we will retrieve this chunk, we will only have a partial information. And the most important problem, so this problem is more when you retrieve it and when the LLM uses it. This problem I'm showing now is more about helping the retrieval process, because our chunk talks about three completely different things: breastfeeding at the top, driving and machinery, and side effects. And so when we will build the vector which represents this information, it will be neither close to semantically to side effects, or driving, or pregnancy, which is somewhere else, but kind of in the middle of everything. And so it will be very hard to retrieve it when asking such questions. So since luckily we know, so all the Vidal is made in HTML, so we know how it's built, and we can just implement some materials to correctly chunk it. And the end result is that The beginning of the chunk and the end of the chunk correspond to a single section. And since one chunk is equal to one section, it's much more easily retrieved when asking a similar question. So this was our improvement boost. And for instance, if we pick the question we just looked at, we can see that now one of the sources we retrieve is clamoxyl in liquid form. And so the answer it gives to this specific question is actually correct. And over only 4 weeks, we managed to improve our performance a lot. Of course, it's still very biased because it's only 100 questions. Important to keep that in mind. And we can see that like our largest improvement is from week 2 to week 3. And it was actually a quite easy trick. Is when a user was asking a question, we were reformulating the question to help the retrieval process. And we asked the reformulating part to input the INN. So I just talked about the INN. It's an international non-proprietary form. And it's basically paracetamol to whatever brand name you are using in the UK. What's the brand name for paracetamol in the UK? Yeah, whatever. A lot of different words, but you know it. And so basically, Elikis here is a brand name. And so you ask the LLM to input the INN as well, and it adds much more information than to the retrieval context because the embedding model are much smaller models than the LLMs trained with much less context. So while an LLM can do the link between Elikis and apixaban, an embedding model cannot. So putting that into your retrieval context really helps the retrieval process. And so this was the prompt associated, so asking to rephrasing using the INN. And what's interesting is that the data science team had no idea what INN was. And it was actually an idea of the product owner, which tried it using the playground of Langsmith. And what's interesting here is that it was really the game-changing iteration of this project, and it's the product owner who found it. And in my personal experience, it's the first time that a product owner could contribute to the iteration, and I really like it. And so with the 2 tricks I showed you, there were some other improvements, but just these 2. This is how the initial pipeline evolved. So the chunking improved, and a reformulation step arrived. So we had 88% of OK answers. Of course, it's on a quite biased data set, but even though we had that much performance, is it enough? So who here knows this book? So yeah, one hand. Hello. So it's Marty Kagan. It's basically a book on which a lot of products from the Silicon Valley were built, like Dropbox, for instance. And it basically says that to build a good product, there are 4 main risks. One is on value. So on our case, will a doctor perceive a benefit using our product? One is on usability. Will a doctor be able to use it? Will they understand how to use it? One is on feasibility. Do we have the right skills and the right budget to build what we want to build? And viability, the business plan. Is this solution viable for a business? And I think it really echoes from the presentation of this morning. If you ask yourself this kind of questions, it mitigates a lot the risk of building a product where you have a very good techno but no value. And so today we're going to focus only on usability and value. So first on usability, will the doctors be able to use it? So to make it usable by doctors, we first made 2 assumptions. The first one is AI is never 100% reliable, so we have to cite our sources, otherwise doctors cannot use it. And doctors only trust reliable sources, so we will directly display the VDAL, which they are used to, in the response. So this is what we did, what we built early on. And so to build this kind of thing, we used Chainlit, which is a framework for building chat applications with LLMs. It's very useful. And basically, you can deploy Chainlit only using Python, but the front end of Chainlit is built using React, and you can so all the front components are built using React. So you can really easily reuse this component to tune them and deploy your own front end. And so this is what we did to basically build something custom to display HTMLs, etc. But our first feedbacks was like, first, I don't understand how the tool chooses the source it gives me. And the second one was the cited monograph is too long, there are too many, and I don't know where the information is taken from. So for the first feedback, what we did is that we gave the doctor the option to choose its sources. So you can click on the arrow button to basically choose the source you want to base your answer on, or consider on the monograph, which allows the doctor to either choose just a generic or brand name, a specific dosage, or all the documents. And the monograph is too long. I can't see where the information is taken from. Another feedback we got, because although we will just show a specific chunk, a chunk could be up to 8,000 tokens, which is quite long. Because some sections on the monograph are over 8,000 tokens. So what we do is that we just decided to highlight in yellow from the retrieve chunk the exact part which was useful for answering the question. And to do so, we just use the function calling ability of OpenAI, which basically return the structured JSON to ask for the beginning of the passage which was useful and the end, and then use just some HTML in the front end to highlight it in yellow. So this helped a lot for the usability. And now regarding the value, does the doctor perceive a benefit using the product? So during the user interviews, we looked at the time it takes the doctors to do a traditional search. Again, another question regarding Levonox, and the doctor took 2 minutes and 42 seconds. It may not seem that much, but when a consultation in France, I don't know how it works in the UK, it's around 10 minutes. The fact that the doctor spends 1/4 of the consultation looking on the VDAL is not ideal. So we compared our tool with, on the same question, how long would it take? So I typed very slowly to mimic a doctor using the application. Yeah, it can take a while, but still be a bit faster. So I'm going to fast forward a bit. So here is what we saw. We can select one source or all of them, and then it's generating the answer. By the way, it should stream the answer, but at the time we built it, there was a small bug with a version of the OpenAI, so the streaming wasn't enabled. Streaming is when you see all the tokens displayed one by one. And then the correct element of the source is displayed, and it took around 54 seconds. So of course, we can still do much better on speed, but it's still much better than what we saw live, and it's true for a lot of questions. So I'm not sure what happened. Yes. So here's where we stopped the project early in January. And we just restarted it at the beginning of the week. So what's next? Of course, it's not in production yet. There is a real challenge. There will be a real challenge for adoption and for usability. So we worked a lot on usability, but it's not finished yet. For instance, we put it in the hand of some new people. They were used to type code, like they used it as they would use the real Vidal. So not asking a question, but just putting in a word. Since we displayed the reformulated question a bit in a way to show the thinking process of the machine, the reaction of another doctor was like, oh, does it think I'm an idiot reformulating my question? We presented it to a conference, to a medical conference to get more feedbacks. And basically, the generated answer is not useful since it cannot be trusted 100% of the time. So we are considering removing it. But still, the highlighting process, it was kind of a wow effect. The doctors really enjoyed it because one of their main pain is finding the right information. So this is what we started working on. But what's interesting is that for the citations to work, we still need to generate the answer because there is something called chain of thoughts in these models. Basically, if you want them to do something quite complex, like finding the right information, it will do it quite poorly. But if you first ask them to think about what they are doing, they will do it much better. And by generating the answer beforehand, they manage to find the citations much earlier, much better. So even though we won't show the generative answer, we're still considering using it. We are also, since we want to scale to a lot of doctors per day, OpenAI will be too expensive. So we were considering using Mixtral at the time, and we tried it, but suddenly the magic of GPT-4 disappeared. And so it's nearly not as good. So we will have to do a lot more iterations if we want to switch to an open source model. And of course, right now, the model evaluation was done fully manually with the help of a doctor whose time is expensive, which really limits the size of the datasets and the frequency of evaluation. 100 questions is not nearly enough. We need to have a lot more. So we are considering improving automatic metrics for the retrieval process because you can do it automatically quite easily, and using LLM as a judge for generation. So using an LLM to evaluate another LLM. So you say, all right, this is the question, this is the answer, this is an example ground truth. Is it all right? Basically, quite simply, to put it simply, and have an evaluation and a test data set, because right now we just have a single evaluation data set, which is, again, we may do some choice which overfits on this data set. So quick conclusion. So on the technical part, so to build a product that works, we really focus on the entire machine learning lifecycle, which is quite interesting, is that with LLM, to my view, the lifecycle did not change. It's much easier to do a POC, but still, you still need to prepare some data for evaluation, to engineer a model around LLMs, evaluate it, deploy it, and monitor again, et cetera, et cetera. And quite often, the evaluation step is skipped, and I think it's a big reason why we see a lot of product not going to production. Thank you very much, and if you have any questions.